Hi everyone. In the given problem statement, there are n gas stations along a circular route. Where the amount of gas present in the ith station is gas I, there is also a cost associated with it to travel from ith station to I plus 1 station. So the gas value is going to be 1, 2, 3, 4 and 5, and the cost is going to be 3, 4, 5, 1, 2. So the difference is going to be minus 2, minus 2. Then from gas station 3 to 5, it's going to be the first time it is coming in. It is still going to be minus 2, 4 and 1. So we can fill up the gas 4 times and the cost is going to be 1. So here for the first time it is coming as positive, and also here is going to be positive. Now a question might arise that here, right, a solution can be possible in case, let's say here, right, the total, a solution is always possible if sum of gas is greater than sum of cost. Then the solution is possible. Now let us have to understand one thing, that when you are at the station 1, right, here even if we fill up a gas of 1 unit, the cost is going to be 3 from going from station 1 to station 2, so we cannot ever reach station 2. Similarly, if you are at station 2, then the cost of filling up the gas means going from station 2 to station 3 is going to be minus 2. Similarly, it is going to be working only at the station 4. Because the cost from going from station 4 to station 5 is just 1, we are going to make a save of 3 unit, and then we can go. Now if we look into it, here the total sum is, let's say, if I look into the subtraction, right, here we are going to get a value of 0. So if the sum of the gas is greater or equal to the sum of the cost, then it's fine for us and the solution is possible. So basically you have to iterate through it and you have to find the first indices, right, where you're going to get a positive value, and you have to loop it through. In case there is not going to be possible, we can go to then iterate to the next one. Now let us look at the Python implementation of solving this particular solution. Now for the Python solution, let me first give our condition where if the sum of gas is basically lower than the sum of cost, then the solution is never possible. So we will return minus 1. Then we will type in total, which is going to be the total gas or the cumulative gas that's been saved, and also the result index, which is currently going to be 0. We are going to loop it. So for I in range 0 to length of gas. Now if total is, before that you have to add one more statement, which is basically total plus equal to the cumulative differential that is getting stored. So gas of I minus cost of I. If total is lesser than 0, then we are going to add a value of total equal to 0, and resultant value is going to be I plus 1, and at the end we are going to return result. Now if we look into this example, during the first case, what you are going to see that the total value is going to be in minus 2. So obviously we will initialize the value of total 0 and result is going to be incremented till it point to the third indices, where the value is going to be first time in positive. So we will have the index which is going to be 3, and it is going to be stored forever. So here we have taken the condition that the solution is kind of possible or always possible in case the sum of gas is greater than the cost. Now if I run the solution, let me look into the public test cases which is passed. Let me submit it. As you could see, the solution has been done, and as you could see, the time complexity of it is 95.78%, which is basically beating it. Here the time complexity is going to be big O of n because we are looping through the loop only one time. That's all for this video. See you in the next one.